Okay, so I'll continue with my example number 3, which on your notes is actually example number 2 on page 2 under first principle. So we are still using the same formula. Remember, this part means go to the formula, wherever there is x, you replace it with x plus h. So I'm keeping my lim, and then I have 1 over x plus h minus 1 over x. I'm not putting the bracket since my f of x is only one term, all over h. So the top part is, in fact, we are subtracting fractions. Remember, when we subtract fractions, we need LCD. And then by looking at these two fractions, my LCD, I will say, is my x and then x plus h. So the method goes like, you suppose when you're adding fraction or subtracting them, you multiply each term with the LCD, then the remainder you multiply it with whatever that is on top. So in this case, if I multiply this LCD here, the x plus h is going to cancel with the x plus h, and then I'll be left with what? I'll be left with the x, and then I take the x and multiply it with whatever that I find in on top, which is 1 multiplied by the x, minus, if I multiply the LCD here, the x is going to cancel with the x, then I'll be left with x plus h. So I multiply the remainder on top. On top I had 1 originally, and then my remainder is x plus h. And you put it all over the LCD, which my LCD is x plus h. Then I'm supposed to say all divided by h, but I don't like working with fractions over fraction over fraction. So what I'm gonna do here, remember, if this is my first fraction and then over this by default is over 1. And if you're changing fraction over a fraction, if you're changing division into multiplication, in fact, you swap one of the fractions. So I'm gonna swap this part. Instead of having h, now I change this division and make it a multiplication. Then I multiply with what? The reciprocal, which is 1 over h. So I swapped the fractions there. So let's simplify. If I break the brackets here, I will have x minus x minus h all over x, and then x plus h multiplied by 1 over h. This will cancel with this one, and then we are left with negative h only. So since this is a multiplication, I can say this cancel with that. Then I'll be left with lim h approaching 0. On top here, I cannot say I'm left with 1. I'm left with negative 1, in fact. Negative 1, because the h and the x's, they cancelled. And here, I will have x squared, allow me to break the brackets, plus xh. So since now I can substitute my h as 0, and then the denominator doesn't become 0, then I'm allowed to do that. I have negative 1 over x squared plus 0. This will be simplified as negative 1 over x squared. So let's just check our answer. If I was differentiating using the rule, my f of x, I can say it's x negative 1. I just took this, I took it from the denominator to numerator, because I cannot use the rule while my variable is on the denominator. So let's see. Now when I do my f of prime x, you take this, you multiply in front, I'll have negative 1, and then x minus 1, that will be minus 2. If I want to have a positive exponent, I will leave the 1 on top and then take this underneath, then it changes the sign to x squared. As you can see, that is corresponding to this one. So this is how you can always check whether your first principle is correct. Just differentiate it using the rule, which is not going to take you long, and then it should be the same as using the first principle.